Welcome to Brain Vision.
Okay, so for this question, we know the rate of change in internal energy should be equal to 0 because the water enters the heater steadily. Okay, so therefore, if we expand the equations on left side and the right side, we'll have m dot h1 plus q dot is equal to m dot h2. M dot here is the mass flow rate of the water we're looking for to determine. H1 is the inlet enthalpy or the initial enthalpy. Okay, and q dot here is the input rate of heat. And H2 here is the final enthalpy or the outlet enthalpy. Okay, so if we do some arrangement here, we have m dot times H2 minus H1 is equal to Q dot. And we know H2 minus H1 can be expressed as Cp times T2 minus T1. Cp is the specific heat for the water, T2 is the final temperature, and T1 is the initial temperature. So if we do some arrangement here, eventually we'll have m dot is equal to Q dot over Cp times T2 minus T1. So we know Q dot, which is the rate of heat transfer, is given as 7 kilowatts. And specific heat for the water is 4.18 kilojoule per kilogram times degree Celsius. We know T2 is 75 degrees Celsius and T1 is 20 degrees Celsius. So therefore, we can determine the mass flow rates of the water in this question by plugging the values here, which is equal to 7 kilowatts over 4.18 kilojoule per kilogram times degree Celsius, and then times 75 degrees Celsius minus 20 degrees Celsius. And this will give us the mass flow rate of the water is about 0.0304 kilogram per second. And this is the answer for this question.